Okay, good evening, everyone. Welcome to O-Level Physics lesson. Today we'll be revising the 2013 Physics Paper 1 MCQ. Okay, today is Tuesday, 11 October 2022. My name is Mr. Chu, and let's begin. Okay, let's start with question number 1. Okay, which diagram shows an instrument that measures a vector quantity? Okay, I got the answer already. Where is all your answer? Question number 1. Begin. Okay, Yuting, well done. Oscar, well done. Ryan, well done. Oscar, well done again. Huaixing, can you send your answer directly to me? And well done to you, Haori, well done. So everybody got the correct answer. And Ryan. Ryan, what's your answer? All right, got the answer correct. Beiguan, well done. Okay, so for the four of these things, the first one is time. Time is a scalar. Temperature is a scalar. Volume is a scalar. Only force is a vector because it has a direction. Okay, which is in this case is down. Okay, so for volume, is the amount of space that it can take up. There's no direction. Temperature is how hot the item is. There's no direction. Time is how fast. Okay, I don't know how to define time. Okay, so basically A, B, C are scalar vector, scalar quantity. Only D is a vector quantity. So answer is D. Well done to everybody. So everybody do question 2 now. Okay, question number 2, I see a few answers. You're supposed to measure directly the circumference of a golf ball. Okay, let me see. Yiting, can you try again? A caliper can only measure the, the diameter. So you want to measure directly the circumference. So what do you use? Okay, Ryan, well done. Huaixing, well done. Haori, well done. Oscar, well done. Beiguan, well done. Okay, so a caliper in this case measures the diameter of the golf ball. The question here is asking you to measure the circumference. Okay, so Yiting, can you try again? Okay, well done, Yiting. Okay, so the answer for 2 is D. Okay, because the tip is flexible, it can wrap around a golf ball to measure directly the circumference of the golf ball. Is that clear? All right, so let's go on to the next one. Question number 3. Okay, let's do question number 3. You all may begin. Okay, I got my answer already. Huaixing, can you tell me what is the definition of period of one oscillation? Okay. Oscar, well done. Beiguan, well done. Ryan, well done. Yu Ting, well done. Okay, so for Hao Rui, well done. Okay, I'm very happy to see that Bei Kuan is not the last to answer today. Okay, keep it up, Bei Kuan. I want to see this kind of speed for the rest of today's lesson. Okay, Huai Xin, can you try again? Okay, very good, Huai Xin. Okay, so for one oscillation, it goes from X to Y to the left side and then back again. Okay, so the period of one oscillation will be 1, 2, 3, 4. 4 times 1.5 seconds will be 6.0 seconds. Okay, so the period of one oscillation is from X to Y, and then go back to X, then to the extreme left, and then come back to X again. This is one oscillation or one complete wave. Okay, so one complete wave is made up of 4 of these 1.5 seconds. Okay, and how many 6 seconds are there in 1 minute? Okay, the answer is B. Okay, all of you got this correct now, so well done. Okay, so let's go to question number 4. Okay, you all may begin. Okay, I got the answer already. Okay, Bei Kuan, wow. Bei Kuan first to give the answer. Well done. Correct. Yi Ting, well done. Ryan, well done. Huai Xin, well done. Hao Rui and Oscar, very good. There's nothing for me to explain for this question. The speed is the gradient of the line. Okay, can I ask you a question? What does the area here represent? Anybody know? What does the area represent? Ryan, well done. How about the rest of you? What does the area under the graph represent? Okay, the rest of you, if you are not sure, just type not sure, or you are confused, or you don't know. Okay, those who were with me since last year, you all know that I always talk about level 1, level 2, level 3, and so on. So level 1 is distance, level 2 is speed, level 3 is acceleration. Did I mention about level 4? Level 4 is actually jerk. Okay, so in a distant time graph, level 1, the gradient tells you the level 2 quantity, which is speed. So in the speed time graph, the gradient tells you the acceleration. So in the acceleration time graph, okay, the gradient tells you the jerk. Okay, same thing. As we go back, the area under the jerk time graph will give you acceleration. It doesn't make sense, okay, but that's how it works. Okay, the area under the acceleration time graph will give you the speed. Okay, the area under the speed time graph will give you the distance. And the area under the distance time graph, in this case, is distance time graph, will give you level 0. So what's level 0? I also don't know. Okay, if I'm not wrong, it's called point. Okay, but at this point, there's nothing here. Okay, there's nothing here. Okay, so this is a trick question. Here is nothing. Okay. So are you clear about this? Okay, so the area under a speed time graph, it actually goes down to the lower level, which you all do not know anything. In fact, last time I got tell you all the level below this is a point. Okay, but in this case, area under a distant time graph does not mean anything. At least for you all to need to know what does it represent. Okay, is that clear? Okay, we are clear. Let's continue. Okay, so I just gave you a trick question. Ryan is very sharp today. Okay, let's do question number 5. You all may begin. Okay, so it's the same thing. Remember I told you about level 1, level 2. Okay, you just need to know 3 level. Okay, this is the displacement, this is the velocity, and this is the acceleration. So now this is a velocity time graph. Your graph is level 2. So how do you find this? Okay, go and calculate. Okay, I got the answer already, and the first to give me was Oscar. Well done. Oscar, correct. Ryan, correct. Yiting, correct. Huai Xin, Hao Rui, Pei Guan, all correct. Very good. Okay, the answer is A. You're supposed to find to find this, you need to find the gradient. So the gradient of this graph, every second, it actually increased by 4 meters per second. Can you see? Okay, so the acceleration of the car is increasingly at 4 meters per second square. Meter per second square means that every second the speed increased by 4 meters per second. Is that clear? Okay, because when we talk about square, the unit doesn't make sense. But if I tell you that this means that every second your speed increased by 4 meters per second, does it make sense to you now? Can? Okay, very good. Let's continue. Question number 6. You may begin. Okay, I got my answer ready. Let's see how many of you got it correct. Okay, well done to Huai Xin. Very good. You got it correct. First to get correct. Hao Rui, well done. Oscar, well done. Yiting, well done. Bei Kuan, can you try again? Okay, who's the last student? Okay, Bei Kuan, well done. Who is the last student? Okay, everybody has answered. Okay, so the answer for this is this. Weight is equal to mg. M is 60, G is 10, so answer is 600. Okay, the resultant force is equal to mass times acceleration. Your mass is 60, your acceleration is 16, and from there you get 960 Newton. Okay, so the answer will be C. Okay, everybody got this correct? Let's do question number D. Sorry, question number 7. Okay, this is a factual question. It's either you know or don't know. Okay, Ryan, well done. Bei Kuan, well done. Yiting, well done. Huai Xin, very good. Hao Rui, excellent. Okay, last student is who? Oscar, very good. Okay, so resist change in motion is actually the inertia. Okay, so well done to everybody. So if you all were born 9 years earlier, you'll be doing very well in this paper. Okay, let's do question number 8. Let's begin. Okay, I got the answer already. Yiting, correct. Bei Kuan, try again. Huai Xin, correct. Hao Rui, correct. Oscar, correct. Ryan, where are you? Okay, so in this case, Ryan, well done. You know that the moon acceleration is low. Okay, so B will be wrong. Okay, so now we compare on Earth, on Earth, on Earth. On Earth, the acceleration due to free fall is about 10 meters per second square. So all these three should actually fall at this acceleration. But which one will fall the fastest? Okay, for A and C, there is air resistance. So after some time, the acceleration will go down. But for D, even though table tennis is very light, there is no air resistance at all. Throughout the whole journey, it will be accelerating at A equal to 10 meters per second square. Is that clear? Okay, so for this question, the answer would be D. Clear so far? Everybody understand? Okay, Pei Kwan, did you give me the right answer or give me the question number 9? Okay, do question number 9, everybody. Okay, I got the answer for question 9 already. Pei Kwan correct, Yiting correct, Hao Rui correct, Huai Xing, well done. Ryan and Oscar, very good. Hey, mass is the amount of substance in a body. Okay, wherever you bring it to, you'll always be the same. You have one atom means it's one atom. Okay, whether it's at the moon or the sun or on Earth, that one atom will still be the one atom. So the mass will remain the same. Okay, whereas or the weight will change because the weight depends on the gravitational force. Okay, so on the moon, the gravitational force is lesser. Okay, so the weight will actually reduce. So for this answer, for this question, the answer is C. Clear so far? Okay, next question. Question number 10, you all may begin. Okay, I got my answer already. Hey, Huai Xing, first to get correct. Well done. Hao Rui, very good. Ryan, Yiting, Pei Kwan, Oscar. Okay, I think you are getting ready for O level. Today, is this paper easy or are you better? Or both? Okay, if you do not know the formula, you can always look at the unit to give you a clue. The unit tells you gram over cm cube. Okay, and gram over cm cube is the mass divided by the volume. Okay, so sometimes we can't remember all our formula, right? I'm not saying that it's okay not to remember, but if you cannot remember, you can always use the unit to give you a clue to help you find out the answer. Is that clear? Okay, let's continue. Question number 11. Okay, you all may begin. Okay, my answer is Pei Kwan, try again. Huai Xing, well done. Yiting, well done. Hao Rui, well done. Oscar, well done. Ryan, well done. Pei Kwan, try again. Okay. So this 5 Newton and the 4 Newton will give anti-clockwise moment. Okay, I let each of this distance be 1 unit. Can? Okay, so the moment, the anti-clockwise moment of the 4 Newton is 4 times 2. So it's 8 Newton unit. Can? Then 5 times 4 will give you 20 Newtons unit. Okay, so far? Okay, this 4 Newton, okay, here is 5 units. will give you a clockwise moment of 20 Newton unit. Is that clear? Okay, so for the whole thing to balance, these 2 Newton should also give you a clockwise moment of 8 Newton unit. Why? Because on the anti-clockwise moment, the total moment is 28. So for the whole thing to balance, it should also be 28. Okay, so the total moment should be 28. So 20 plus 8 is 28. But because the force is 2 Newton, how far away from the pivot will it give you a 8 Newton unit? Okay, it should be 4 unit away. Okay, so this will give you 8 Newton units. Okay, Bei Kwan, are you clear about this? Okay, Bei Kwan, if you understand, give me a thumbs up. Okay, all of you do question number 12 now. Okay, question number 12. All of you got it correct. Well done. Okay, so for this question is D. For question number 12 is A. Okay, so to have the most stable, what are the two factors that give you stability? The lower the center of gravity or the greater the base. Is that clear? All right. Okay, so very good. Let's continue question number 13. You all may begin. Okay, Yuting, can you try again? Huai Xing, well done. Haori, well done. Ryan, well done. Oscar, well done. Bei Kwan, try again. Okay, Bei Kwan, try again. Okay, so what is the net pressure? The net pressure is 105 kilopascal minus 103 kilopascal will give you 2 kilopascal, which is 2000 pascal. Okay, and we also know that pressure is equal to force over area. You want to find the force, I need to put pressure times area. Okay, so from this, can you all do the answer now? Okay, Yuting, well done. Bei Kwan, well done. So are you clear about this? So 2000 times 4 will give you 8000 Newton. So the answer is B. Okay, do question 14, everybody. Do question 14, everyone. Okay, I got my answer already. Huaxing, I'll ask you, would the pressure P to be able to push the mercury up like this, right? Would the gas pressure be greater or less than the atmospheric pressure? Okay, you go and try again yourself again. Howry, well done. Oscar, well done. Ryan, well done. Bei Kwan, well done. Okay, Yuting, well done. Okay, Huaxing, you try again. Okay, Bei Kwan incorrect, Sorry, Bei Kwan incorrect, Okay, Huaxing, well done now. Okay, let me explain to you this question. Okay, first of all, I want you all to see here in this line, okay? This line and this line, these 2 points A and B have the same pressure. Do you agree? Okay, so pressure at B is the same as pressure P because the gas pressure is pushing at B. Then pressure at A is the same as the pressure pressing down by the things on top of it. Okay, so there is an atmospheric pressure pressing down, which is H. And then you add the X, the amount of mercury on top of it. Okay, so you know that at A is equal to X plus H. Then B is P. And A and B, they are on the same height. They have the same amount of pressure. So can you conclude what is the pressure of P? Okay, Bei Kwan, can you conclude what's the pressure of P now? Okay, well done, Bei Kwan. Okay, so for this question, okay, you need the pressure of P is the same as X plus H. So answer is A. Clear? Okay, next question. Question 15, all of you may begin. Okay, this question, if you don't even look at the question, right? You're comparing work done with these four quantity. Which of these four quantity is equivalent to work done? Can we say is the acceleration equal to work done? Cannot, right? Because acceleration is acceleration. Okay, work done is measured in joule. Acceleration is measured in meter per second square. So they are not the same. So which of these four quantity is equivalent to the quantity of work done? Okay, so from here you should be able to get the answer. Let me see whether you got it correct. Huai Xing, well done. Yu Ting, well done. Hao Rui, Oscar, well done. Ryan, your second answer is correct. And Bei Kuan, which of these three quantity is the same as work done? Okay, well done, Bei Kuan. Okay, so the answer for this will be B. Okay, so all we got it correct. Okay, let's continue. Okay, question number 16. You all may begin. Okay, Bei Kuan, well, wait, Bei Kuan for 15 is correct. Yu Ting, well done. Hao Rui, well done. Oscar, well done. Bei Kuan, well done. Ryan, very good. Okay, Huai Xing. Huai Xing, do you know how to do question 16? Okay, the rest of you do question number 17. Hey, this year paper is like very easy. Oh. Huai Xing, are you there? Okay, Yu Ting, 17 correct. Hao Rui, 17 correct. Oscar, 17 correct. Huai Xing, are you there? Are you there? Ryan, why is your camera off? Huai Xing, hello. Okay, Bei Kuan, your 17 is correct. Very good. Can you all hear me, everyone? If you can hear me, give me a yes reaction. Thank you, Bei Kwan. Huai Xing, what's your answer for 16 and 17? Okay, Huai Xing, your 16 is correct. Okay, so all of you got the answer for this. Okay, well done. So the work done is the same as the gravitational potential energy gain, which is mgh. Mg is your weight, which is 600. Height is your tree, is the height of the staircase. So your answer will be, sorry. Okay, I'm sorry. For number 16, all of you got it correct, which is actually B. Okay, so for Huai Xing, it is not 3000. It's actually this one, mgh, which is 1800 joules. Is that clear, Huai Xing? Okay, for 17, Ke is equal to half mv square. You sub in everything, you should get the answer D. Okay, so Huai Xing, you understand why the answer is B for 16 and not D? Okay, we use the height 3, not this distance. Clear? Because the weight of the person is going down. Whereas this distance is not in the same direction as the weight. Okay, so it must be the same direction. You choose the 3 meters. Is that clear? Okay, now everybody do question number 18. Do question number 18. You all may begin. Okay, I got my answer already. Bei Kwan, can you try again? Ryan, well done. Oscar, well done. Yu Ting, well done. Huai Xing. Huai Xing, try again. Hao Rui, well done. Bei Kwan, try one more time. Okay, what's the formula you need to know? Okay, power. This is power. Power means every second, how much energy is used. Clear? Okay, so power is the same as energy over time. Okay, so you want to find energy, you rearrange, you get power times time. In this case, the power is 2500. You must change this to the SI unit, which is second. So the time itself is 3 times 60. From here, what answer do you get? Okay, Huai Xing and Bei Kwan, do you know what's your mistake you made in this question? Okay, so the answer is 450,000 joules. Okay, so have you all learned why you got a mistake, why you made the mistake here? Bei Kwan, you okay? Thank you. Let's continue. We are halfway there, almost halfway there. Okay, let's do question number 19. Okay, I got my answer. Yi Ting, well done. Hao Rui, well done. Oscar, well done. Huai Xing, well done. Okay, how about Bei Kwan and Ryan? Bei Kwan, very good. Hey, Ryan, your camera is off and you haven't given me the answer. What happened to you? Okay, very good. All of you got this correct. Okay, sunlight give you heat. Okay, so the temperature increase. And when the temperature increase, the gas pressure increase, but the mass has no effect because if there are 5 molecules of air in the tire, you still have just 5. Okay, the mass will not increase. Okay, question number 20, you all may begin. Okay, 20. Yi Ting, well done. Oscar, well done. Hao Rui, well done. Bei Kwan, well done. Okay, where is Ryan and Huai Xing? Huai Xing, very good. Okay, Ryan, where is your answer? Okay, everybody got this correct. Answer is D. Hey, do you find this year the 2013 paper is so easy? It's different from other years, right? Okay, question number 21, you all may begin. Okay, I got my answer already. Huai Xing, well done. Yu Ting, well done. Very good, very good. Ryan, Bei Kwan, Hao Rui, and Oscar all got correct. Well done. Let's do question number 22. Okay, begin. Okay. 22, Oscar, very good. Huai Xing, Hao Rui, well done. Yu Ting, well done. Bei Kwan, try again. Ryan, how about you? Ryan, well done. Bei Kwan, well done. Okay, Bei Kwan, what was your mistake? Okay, the answer is C. This is melting ice is 0 degrees Celsius. Okay, wet steam is 100 degrees Celsius. So you know this is 0, this is 100. If you calculate, this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so the answer is 70 and therefore the answer is 70. Is that clear? Okay, let's continue. 23. Okay, you may begin. Question number 23. Okay, 23. Okay, let me look at 23. I see two answers that is correct. Okay, question 23. Let me see. How Ray says D. Bei Kwan says B. Huai Xin says D. Ryan says D. Oscar says D. And the last student is who? Yiting, what's your answer for question number 23? Yiting says both. Okay, so which one is more correct? B or D? Okay, which one is more correct? Okay, so all of you know that A and C are definitely wrong. Okay, so which one is more correct? B or D? When boiling occurs, okay, the only thing that I would say that B is incorrect is because of the word air. Okay, so the only thing that I feel that's incorrect is because of the word air. So if you were to boil water, you don't produce bubble of air, you produce bubble of steam. Okay, if you boil oil, for example, you don't produce bubble of air, you just produce bubble of the gaseous oil. Okay, so in that case, bubbles of air, because of the word air here, I will say that B is incorrect. Is that clear? Okay, and then evaporation also doesn't occur at all temperature. When the evaporation, when the material is a gas or a solid, you also will not evaporate, right? Okay, but between B and D, D will be a better answer. Is that clear? Okay, let's do question 24. How Ray, can you share your answer, your question to everybody? How Ray says that the bubble rising from the bottom to the top and not the whole liquid. But do you also remember when you boil a liquid, the whole liquid will be of the same temperature because it boils at a fixed temperature. So by right, yes, convection occur. Okay, hot gas rises and so on. However, when you start to boil something, it's a whole thing that boils. Okay, so in that sense, Ray, what you say is not wrong. Okay, but because pure substance boil at the same temperature. Okay, so if you were to boil the whole thing, okay, boil the whole thing, by right, the whole thing will be at that same temperature. So therefore, the whole thing will boil. Is that clear, Ray? Whereas for evaporation, it only occurs at the surface. That's why it's slower. Okay, all of you do question 24 now. So Ray, are you convinced with my explanation? Okay, question 24, Yiting, correct. Huai correct. Howard, well done. Oscar, well done. Okay, Ryan and Bei Kwan, what's your answer? Okay, Bei Kwan, well done. Ryan, well done. Okay, so for this question, the answer is B. All of you got it correct. If you need me to explain, let me know. If not, just go on to question number 25. Okay, do question number 25 now. Okay, 25, Oscar, very good. Bei Kwan, very good. Yiting, very good. Howard, very good. Left with Huai Xin and Ryan. Okay, Huai Xin, well done. Ryan, what's your answer for question 25? Okay, Ryan, well done. Okay, so amplitude is the maximum displacement. So it is displacement. The original position is here. How far is it displaced? The maximum displacement will be B. Is that clear? When there's no wave, they are all along the dotted line. So amplitude is the maximum displacement, the maximum distance that the thing is displaced. So B is the maximum displacement from the original position at the dotted line. Okay, so question number 25, well done. So everybody do question number 26 now. Okay, 26, I got my answer already. Oscar, well done. Hao Rui, well done. Huai Xing, well done. Yu Ting, well done. Okay, Ryan and Bei Kuan, what's your answer? Okay, 26. Bei Kuan, well done. Ryan, well done. So all we got it correct. Answer is C. Okay, so let me just go through very quickly. V is equal to F lambda. F is 1000, lambda is 0.1. So the wave is traveling at 100 meter per second. Okay. So for it to travel 2500 meters, it will take about 25 seconds. Oh, very fast. 27. Okay, so what's the answer for 27? What is the focal point of the lens? Oscar, very good. Yu Ting, very good. Bei Kuan, well done. Okay, Bei Kuan, well done. Hao Rui, well done. And Ryan, very good. 1, 2, 3, 4, 5. Huai Xing, what's your answer for question 27? Okay, Huai Xing, very, very good. Okay, so answer is D. Okay, so I will need not explain question 27. Let's continue. Okay, question 28. You may begin. Okay, 28. Huai Xing, very good, correct. Yu Ting, well done. Hao Rui, excellent. Oscar, very good. Okay. Bei Kuan, well done. How about Ryan? Ryan, where are you? Ryan. Okay, 29. Everybody try doing question 29. Yu Ting, 29, correct. Ryan, what's your answer? Ryan, your A 28, 29 are correct. Hao Rui, well done. Bei Kuan, well done. Okay, 28. If we are choosing both that are the part of the EM electromagnetic spectrum, you should be correct. Okay, so for question number 28, it should be okay, if gamma ray and infrared, because both of them are EM wave. Okay, if both are EM wave, they should be traveling at the same speed. Whereas for sound and ultrasound, they are not EM waves, so they will not be traveling at the same speed as the EM wave. Okay, question 29, Hao Rui, Bei Kuan, correct. So whoever give me 29 yet? 1, 2, 3, 4, 5. One more student haven't give me 29 yet. Who are? Okay. Huai Xing, what's your answer for 29? Okay, well done. Okay, so for 29, it's a factual question. It is B. Okay, so all of you got it correct. Keep it up. Okay, question number 30. Come, 30, what's your answer? I got the answer from Ryan, correct. Yiting, correct. Oscar, Huaixing, correct. Hao Rui and Hao Rui, correct. Bei Guan incorrect. The electric field tells you the direction. For example, if I got a lot of field here. Okay, what does this line tells you? If I put a positive charge, for example, I put a positive charge here. Okay, if I put a positive charge here, it will move along this line in this direction. Is that clear? So now, what is the direction of the electric field here? So this is the negative charge moving to the right. Okay, so you know that the field should be left to right. Okay, so the direction is to the left or right. Okay, Beikuan, it is left because this is the negative sign. So you do the opposite. Understand? Okay, we are left with 10 questions. Today we may end slightly early. Okay, do question 31 now, everyone. Okay, this year paper is very easy, compared to the last 2 years. Okay, 31, I got the answer already. Yiting, Huaixing, Oscar, Ryan, Beikuan, Hao Rui. All of you got it correct. Well done. Okay, so from here, you can know that the current is 2 ampere. Okay, so power is equal to VI. Power is 24. Your V you don't know. Your I is 2. So therefore, your answer is B. Okay, your potential difference need to be 12 so that this equation is correct. Okay, everybody do question number 32 now. Okay, I got my answer for 32 already. Yiting, well done. Huaixing, well done. Beikuan, you try again. Oscar, Hao Rui, and Ryan, very good. Okay, what's the formula of PD? Okay, PD is work done, okay, by every unit charge. Okay, so this is the formula. PD is the work done carried by every unit charge. Okay, so what will be the answer? Okay, so the answer will be D. Well done, everybody. Okay, we have 8 more questions. Okay, I'll do question number 33 now. Okay, question 33. This year paper really very easy, right? You all think so or not? Okay, Huai Xin correct, Yi Ting correct, Hao Rui, Bei Guan, Ryan, and Oscar all correct. Well done. Okay, answer is A. Okay, very good. Well, this year everybody should be very happy. Okay, question number 34, you all may begin. Okay, Bei Guan, try again. Yi Ting, well done. Huai Xin, well done. Hao Rui, well done. Ryan and Oscar, well done. Okay, when it's a positive, they should move this way. Okay, it should move this way. So if Bei Guan, if you put your diode in this manner, you're forcing the current to go this way. So this is the normal usage. Okay, but now you mentioned that the current is in the opposite direction, will recharge. So you want to recharge, you want your current to be moving this way. So which setup will you choose? Bei Guan. Okay, well done, Bei Guan. So the answer for this will be A. Is that clear? Okay, let's continue for the next question. Question number 35. You all may begin. Okay, I got my answer for 35 already. Okay, all of you got it correct for 35. Well done. Waiting for Ryan's answer. So the rest of you do question 36. Okay, for 35, the answer is A. Well done. Okay, let's do question number 36. Okay, 36 is also very easy. Okay, 36, what's your answer? Ryan, very good. Yu Ting, very good. Huai Xing, very good. Oscar, very good. Hao Rui, Bei Kuan, very good. Okay, iron is the soft magnetic material. Okay, iron is a soft magnetic material, so you can choose. Okay, so that you can actually get magnetized faster and slower, and you also can have a strong magnetism. Whereas for steel is a hard magnetic material. It is harder to magnetize. Okay, but once it magnetizes, you'll stay magnetized for a long time. Okay, so 36, the answer is C. Okay, question number 37. All of you, you all may begin. Hey, this year paper is really very easy. Yi well done. Huai Xing, well done. Hao Rui, very good. How about the other three of you? Ryan, excellent. Bei Kuan, well done. Oscar, well done. Okay, correct. If you make your battery weaker, you will get a smaller distance. Is that clear? So either your current is lesser or your magnet is lesser, you produce a lesser force. So this is a force. Okay, so to reduce a force, either you reduce the current or you reduce the magnetism. Is that clear? Okay, next one, question number 38. You may begin. Okay, I got my answer for 38. Okay, 38, Yu Ting, well done. Huai Xing, well done. Bei Kuan, well done. Hao Rui, Ryan, and Oscar. Very good. Okay, so all of you got this correct. Okay, what happened here is this. If I got two crosses, if I were to use the right hand grip rule, I will get something like this. Okay, same direction. Okay, but because this will even out, therefore you'll end up with something like this. Okay, so when you get something like this, you push them together and therefore answer will be C. Is that clear? Okay, let's continue. Question number 39. second last question. You all may begin. Okay, I got my answer. Yuting, correct. Ryan, well done. Huai Xing, very good. Oscar, well done. Bei Guan, try again. Hao Rui, well done. Okay, when there is more coil, you get higher voltage. When there's less coil, you get lesser voltage. Is that clear? And because power will remain the same if there is no efficiency loss, the current at the right side will be lower. The current at the left side will be higher. Is that clear? Okay, so Bei Guan, B is wrong. Okay, so for this question, the answer will be A. All of you got it correct now. Well done. Okay, let's go to the last question. Wow, this year paper is unbelievably easy, right? Okay, you may begin. Question number 40. Okay, once I call your name, if you have now no question for me, you may leave. Ryan, you may go. Howard, you may go. Oscar, you may go. Bei Guan, you try again. Yuting, you may go. Okay, if you have any more, if you all have any question, you may stay back to ask me. Huai Xing, you stay back for a while. Bei Guan, try again. Yuting, can. You stay back for a while. Ryan, you may go. Okay, so basically in a long transmission line, you can assume that there is a resistor. There's a resistance in the wire. Is that clear? Okay, there's a resistance in the wire. So before there are two resistance. Okay, there's a voltage here, there's two resistance. After that, if one is closed, what happened to this voltage here? Okay, so the resistance of this Y is the same. Okay, but the total resistance here, is lower. Okay, the resistance here is higher. Okay, so there will be a rise in the voltage supply. Okay, can you imagine when there are two resistors here, the total resistance will be lower because it's parallel. Okay, so the total resistance is lower, so the voltage is lower. But now there's only one resistor. Okay, the voltage will be greater. Is that clear? Okay, and therefore there is an increase in the voltage supply. So answer will be C or D. But which one do you choose? Okay, Bei Guan, which one do you choose? Is it C or D? Okay, next thing you need to know is power is VI. Since there's no I that's been given to you, right? You know that power is V squared over R. So the R here is the same. But since the V increases, your power will increase as well. Is that clear? Okay, so Bei Kwan, the answer will be C, and therefore the answer is C. Understand, Bei Kwan? Can you practice a bit more? You are improving. Okay, and I see that you're improved. Are you happy that you're improved? But you need more practice, Bei Kwan. Okay, Bei Kwan, you may go. Okay, thank you, everybody. Let me stop the recording.